Hi, I'm Brian from Simply Brian Enterprises and welcome to my channel. This week we're going to be looking at the homework solution for TopTechBoy's Raspberry Pi class, lesson number 12. If you saw my last video for lesson number 11, you'll know that we worked on a 3-push-button circuit that controlled 3 color channels on an RGB LED. The red push button controlled the red channel, green push button on the green channel, blue push button on the blue channel. Of course, last week we just did a simple latching circuit of press and hold to turn the light on, press and hold to turn the light off. This week we're going to go to the next logical step, which is introducing PWM so we can actually control the brightness of each color channel, giving us the ability to actually mix at a more granular level the red, green, and blue colors together to make new colors. So as we often do, the first thing we're going to do is look at the hardware. Then we'll run the program, and then we'll take a look at the code. The hardware really hasn't changed from last week. Still have Paul wearing a red shirt, Paul wearing a green shirt, Paul wearing a blue shirt, my common anode RGB LED, and of course our ever so popular Cat Talk button to help us exit the program cleanly and reset the LED status. So let's take a look. And let's get started with the program. I wanted to point something out because Paul has made this mistake a couple of times in his classes, and I just wanted to point out that what I'm doing is not a mistake. I actually intend to do it this way. You'll notice that when I run my code, I'm running it as Python, not Python 3. And the reason I can do this is because I'm in my virtual environment. If you go back several videos to when I set up my Python environment on the Raspberry Pi, you might remember that I created these virtual environments, set up all my little variables and things, and that way when I'm in my virtual environment and I just type python -- version, you see I'm running Python 3.9.9. So even though I'm running this as Python, as long as I'm in my virtual environment, I know I'm running the correct version of Python. Just thought I'd point that out in case anybody caught that. And now, without any further ado, let's get into the program. So the first thing we're going to do is we're going to, once again, just do the color channel check of red, green, and blue to just flash the LEDs. And now we begin starting our colors. You'll notice that I'm actually writing RGB values to the screen. That way, as I'm running the code, I can keep track of what colors are which. And as I mix colors, which values are getting mixed. And you can see that just by pressing buttons, I'm actually changing the color from one to another. I'm going to turn off this light to see if the camera picks up the color a little better. Because right now it's kind of a strange magenta as I look at it. And I don't know that the camera's picking that up quite as well. But you can see I can mix the colors. And I've gone on the red channel all the way from starting at 51, now I'm up to 255. Now, interesting problem is, what do we do with PWM when we only have one push button? If we had 2 push buttons per color, it would be easy to have an up push button and a down push button. So we have to make some code decisions about what happens when we hit 255, what happens when we hit 0. So I made the decision that in the same way I'm incrementing a step, I'm going to use the push button to decrement. So now I'm at 255. I press the button 204, 153, and you can see I'm decrementing down all the way to 0. The red channel is now off. And I can do the same thing with the green channel. Walk it up, walk it back down. Blue channel, walk it back down. Or I can just hit the Cat Talk button, and the Cat Talk button clears the LED status. And of course, if I hit the Cat Talk button a few more times, strike 3, you're me out. Too much cat talk in here. All right, now let's take a look at the code and see how I did this and some of the design decisions I made, because quite honestly, I made some questionable design decisions, but I don't mind sharing them. I would love to hear your feedback. So very similar code to last week to start off. We've got our Cat Talk information, the pin and setting the counter to 0. We've got our in pins and out values. And again, I've signed these as dictionaries using red, green, and blue. I've added a new dictionary called RGB last val, and that is because as we start to work through the code, we have to keep track of where we are in the process. Are we, if I press the red button, do we increment or decrement? Which direction do we go? And we have to use some sort of a status value to keep track of which direction we're going to go and make a decision based on that. So I have this dictionary called last values. And we kind of come down through here. Again, we set up our output pins, our input pins, our cap talk counter pin. And we get down to this tweakable section. We're going to set the LED frequency to 100. Seems to be a good value. The camera seems to like that one. And I've also added a new value, and this was a design decision that I was toying with in lesson 9, but didn't really have the time to implement. And that is, as we're doing PWM, we have to decide how many steps are we going to take between lowest value and highest value. And what is that incremental value in between? And I thought that there's a way to do it mathematically. However, with lesson 9, I kind of ran out of time and didn't quite have my idea fully formed. But in this step, we actually have the number of steps tunable. So in this case, I hit red 5 times, I go from 0 to 255. I hit it again 5 times, I go from 255 to 0. I could change this to 3 steps, 4 steps, 10 steps, however many steps. And of course, the more steps, the more granular and the better color mixing I'm going to be able to do with the RGB LED. And as we get down further in the code, I'll show you how we actually do the math on that. And once again, we have our PWMs. We're using a common anode RGB LED, which means we're doing a sinking current instead of a sourcing current. So when I start my PWMs, I want to start them at maximum value, which actually means 0 on a sinking current, whereas we'll go from 100 to 0 to make it brighter, as opposed to 0 to 100 as you would on a common cathode LED. And then we get into this section where we just flicker the LED just to check all our color channels, make sure everything's working. We set up our RGB output values at 0 to start off. And then here's where I'm taking that step counter, and I'm just doing a 256 divided by the step counter, and that gives me my interval. So in this case, as you may have caught when I did the code, that step interval is 51. That's rounded. It's not exact because I'm doing basically an integer, round down greatest integer. So, but it's close enough. So with that all set up, now we head into our loop. Now, there's this concept that if you're driving down a city block, let's say you want to take a right turn. So you come up and you go right turn. Well, what if you miss your right turn? What's the other option? Well, what you can do is you can go down another block, take a left turn. I'm off the screen. Hold on. Take a left turn, another left turn, another left turn, and now you basically just made a right turn that you missed. So we have this saying, 2 wrongs don't make a right, but 3 lefts do. And in this case, we have what I call in this code, 3 lefts make a right. So the first thing we have to do is, I made a design decision in the push button code when I'm augmenting the value that I'm going to use an RGB scale from 0 to 255. If I'm incrementing, I'm going up. If I'm decrementing, I'm going down. But I'm going to actually use this 0 to 255 scale that we use elsewhere in code. That means I have to do some conversion when I write it out to the LED to make sure that that value is actually getting written correctly. So the first thing I have to do, or what I call the first left turn, is I need to invert the value. 255 has to become 0, and 0 needs to become 255. And the easiest way to do that is just take 255 minus the value, and that just flips it around. You'll also notice that even though these are all integer values, I'm going to force them into a floating value because I'm going to do some other math and I want it to be more exact than using integers. And as we walk through, I've used an example input value. So let's say that I've passed it an RGB value of 64. Well, now we took left turn number 1. We're now inverted to 191. Then we're going to translate it. So this is left turn number 2. We're going to translate it from RGB to PWM value. We're going to go from a scale of 0 to 255 to a scale of 0 to 100. And the easiest way to do that is just say 255 divided by 100, or actually take the value divided by 255 divided by 100. Now I could have just put 2.55, but for educational purposes, I wanted to leave it expanded out. I didn't want to just put 2.55. I wanted to actually show where I derived that number from. I'm taking my maximum value on the 255 scale divided by my maximum value on the 100 scale, and then dividing that value from the RGB value. And so as we come down here, remember we started off with an RGB value of 64. We then flipped it to be 191. Now we've translated it from 255 to 0 scale to a 100 to 0 scale, and our new value is 74.9. Now we come down to left term number 3. As you remember, the PWM output is exponential, not linear. So we have to convert our 0 to 100 scale from linear to exponential. And the way we're going to do that is we're going to take that value divided by 100, raise 10 to that value, and then multiply the resulting value by 10. That gives us, again, a scale of 0 to 100, but it's now an exponential scale because we took the exponent of 10, and now we've basically converted it from linear to exponential. Once again, we have that single corner case, whereas if our RGB value is 0, we actually end up with a value of 10, which is visible, so we want to make sure we rewrite that as 0, and we do that for all 3 colors. So once again, we took 64, translated it to 191, translate it to 74.9 in the linear scale, and now we've translated it and we end up, oh, and I should point out that after I did all this exponential math, I converted it back into an integer because now I'm done with all of the floating point accuracy, and an integer is fine. So now I have integer of, excuse me, I need to read this, 56.104 equals 56. So now we've got our initial value of 64, which is basically 25% brightness, to 191 to 74.9. And now we have 25% brightness is translated as 56. And then we go through the process of writing it out. We do our change duty cycle. All right, so how do we actually augment the RGB value by using the push buttons? Well, we use this all familiar code. I'm using the pull up button. So I look at false, hold it down, release, and we hit this line of code. So the first thing we have to do is we have to look at what is that value. What is the current value before we augment it? If it's 0, well, then we know the only direction is up. So the only decision we have to make is we're going to increment it by the step value. What we're going to do then is we're going to take the current value and I'm going to write it out to the last value. So when we start to step up, you'll see the need for that last value. Before I change it, we're gonna write it out to the last value. Then we're going to increment it, step up. So in this case, if it was 0, I'm going to write last val as 0 and increment the RGB value to 51. So now when I come out of this, my last value is 0, my new value is 51. On the flip side, if it's 255, I know that I have to go down. So now I'm going to, just like before, I'm going to set my last value as 255, and I'm then going to decrement it. So now I have my last value of 255, My next value, in this case, it's minus 51, so it'll be 204. Then I have all the in-between values. This is where I really start to use that last value, because I have to look and say, okay, if the current value is greater than the last value, that means I'm going up. So I need to increment. If the last value is less than, then I need to, or rather, if the current value is less than the last value, then I need to decrement. I'm going down. Now, of course, all of this incrementing and decrementing, we're going to eventually, no matter what, it's unavoidable, we're going to hit rounding errors. And what's going to happen is eventually we're going to get a value that is out of bounds between 0 and 255. We're going to get a value of -1 or 256 because we incremented or decremented by one too many. So I have to do some bounds checking. If it's less than 0, that means it's really 0. If it's greater than 255, that means it's really 255. That way I know when I come out of this code, I am sending a value that is a valid RGB value between 0 and 255. And then I go through the step of printing it out to the screen because I want to see when I'm pressing this button and I'm augmenting the LED, I want to know what those RGB values are that are being sent, somewhat for debugging, but also because of the complexity of this code and what I'm doing, I want to keep track as I'm using the program what's going on. And then, of course, every time we touch a color button, we clear the cat talk counter. We do this 2 more times. We have a green section, a blue section, and of course we check for the cat talk input, and then we loop back around. And of course, every time through the loop, we're going to take whatever that current RGB value is, run through the math, and then write it out as a PWM status to the RGB LED. Too much cat talk, 3 strikes, and you're meowed. We're going to set the duty cycle to 100, so we're going to set the sinking current to 100 to turn off the LED. Sometimes, if you don't do this step, the LED will come on to its last state the next time you run the program. Not always, but sometimes. So I always want to make sure I set the duty cycle to off, and then I want to make sure I stop my PWMs, and then we do the GPIO cleanup to exit the program. So I hope you followed that because it is convoluted, it is complicated, and maybe I overcomplicated it, but I think I made a good design decision here because what I'm doing is I'm taking these buttons and I'm using the raw RGB values 0 to 255. I think in future lessons this is going to be an advantage to me because even as I look to lesson number 14 where we start playing with VPython and we're going to start augmenting an LED that's on the screen, I think it's going to save me a lot of coding, a lot of time and headache because I already have the RGB values. So if I have on the board, here, boom, 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 you know, so I've got like 255 red and 192 green and 64 blue, whatever color is represented here on the LED should be relatively simple to represent in the VPython world without adding a lot of code. Basically, I'm just going to have to design my LED and then force my color values in RGB. I won't have to do any math to do that. So I think I made a good design decision here, but we'll find out for sure when I actually work on lesson 14. And of course, that's going to be a topic of conversation when we get there. I really hope you liked this video. If you did, be sure to hit like and subscribe below to my channel and leave a comment. I'd love to hear your thoughts. I think this is a complex, convoluted solution. There's probably a better way to do it. I'd love to hear your thoughts below. Until next time, I'm Brian from Brian Enterprises, and thanks for watching.